So we are going to look at problem 22.42 of the textbook, and this deals with a uniform electric field. If you're super confused about this, I recommend seeing example 22.8. Instead of reading off this statement itself, I'll just explain what's happening here. So the problem tells us that we have this electron right here, this negatively charged particle, that is entering this area of uniform electric field. Now remember, an electric field is pointing in the direction of motion of a positive charge. So if I did place a positive charge inside here, it's going to move up like this. Of course, I have a negative charge, so it is going to want to move down, right? It starts here at position 0, 0 with some initial velocity in the x direction. Because of the electric field, it's going to feel the force down in the negative y direction that's going to be pulling it down into this curved path, and it is going to, at some point, exit the parallel plate capacitor system. Now, if I know that the parallel plate capacitor has this length here of 0.200 meters, that means this corner right here is going to be at x is equal to 0.2 meter, right? Now, if I start off at 0, 0, and I know that the separation of the plates is 0.015 meters, I know that this bottom right corner is going to be at, so we know 0.2 meters, negative 0.015, right? So this is where this corner is, and I want to know, where does my electron exit? Like, if the electric field isn't that strong, it might not curve that much, and it might exit way up here. Or maybe if it curves a lot, it is going to exit way at that corner. So I'm trying to figure out where it exits. In other words, I want to know, what is y final when x final is equal to 0.200 meters. So when this is my final x coordinate, what is my final y coordinate? That's the question. I'm given a whole bunch of numbers that I can use to figure this out. For instance, I'm told that the magnitude of the electric field is equal to 200 newtons per coulombs, and we know that this is in the positive y-hat direction. I'm told that L, the length of my plates, is 0.200 meters. I'm told that their separation is equal to 0.0150 meters. I'm told that it has an initial velocity of 3.00 times 10 to the 6 meters per second in the positive x-hat direction. So again, I want to figure out where it exits. I know some of my kinematic equations, like this one. X final is equal to Vxi times t. And I know that y final is going to be equal to 1/2 ay t squared. So here I know, I should clarify that this is true because I know that x initial is equal to y initial, and these are all 0. I start at position 0, 0, so I can say this. Now I know what I want my x final to be. I know what my initial velocity is, so I know that t is equal to x final divided by vxi. I can plug that into this equation here. So I get y final is equal to 1/2 a in the y direction, xf divided by vxi squared. Now, what is my acceleration? Well, I also know that because my electric field is only in the y direction, my acceleration in the y direction is going to be equal to q ey divided by m. This just comes from the fact that we have mass times acceleration is equal to the force, which is q times e, right? So this is the equation that I'm going to use, and I'm going to plug that into this equation here. So y final is equal to q ey divided by m, xf divided by vxi squared. So this is my equation. Now I know a few things. Well, I know pretty much everything I need to know, really. I know that I also dropped a 1/2 somewhere. So here I had a 1/2 a, so that needs to have a 2 there. So if I plug everything in, y final is equal to q, which here we know is negative e because it's an electron, times ey. So why don't I just go ahead and write, instead of just saying negative E, well, I know what E is for an electron. So it's negative 1.60 times 10 to the negative 19 coulombs. I know that E in the Y direction is 200 newtons per coulomb. I know that I have XF, X final, which is 0.200 meters. Square that. That doesn't look really pretty. I divide that by, then I have my 2, and then I have the mass of my electron, so 3.00 times 10 to the 6 meters per second. Square that. And then I have, sorry, this is the velocity, not the mass, right? So this is the velocity squared, and then the mass is 9.11 times 10 to the negative 31 kilograms. So I plug in all of that, and as an answer, I get negative 0.0781 meters. Now, if I go back to the original question, it asks me, why is this impossible? And to figure that out, I could just draw it here. So I have my parallel plate system. I start here, and I know that at this corner, I'm at y is equal to negative 0.0150. This is negative 0.0781, which means I am way, way down here. That means when I exit my parallel plate capacitor system, somehow my electron got way down there. The reason why that's not possible is because that follows a path like this, right? And I mean, this is an actual plate, and my electron can't just magically fly through my plate. The thing is, though, that my equations don't know that there's a plate there. I do. So I have to say, like, okay, obviously this can't happen. My electric field was either way too strong, or my plate system was just way too long.